I should have already posted. Alright, so here your family spent 2 hours at your grandparents' house, okay, which was 20 miles away from home. Okay, 2 hours at grandparents' house. So we don't know where they've been before that. So at 0, you're still 20 miles away from home. Okay, still 20 miles away from home. 2 hours at your grandparents' house. So at 1 hour, you're still at the end of 2 hours. You're at 20 miles from home. The distance have not changed. You're at your grandmother's house. From your house is 20 miles. From your grandparents' house, your parents drove 50 miles per hour for 3 hours to go to Magic Mountain. Okay, 50 miles per hour for 3 hours. Okay, so for the first hour here, it's add 50, you get 70. That's 1 hour. Add another 50 here, you get a 120. That's 2 hours, that's 250. Add another 50 here, that's 170, that's 3 hours. Okay? Your family stayed at Magic Mountain for 4 hours. So at 170 miles from home, your family stops for 4 hours and stayed at Magic Mountain for 4 hours. Here's hour 1, hour 2, hour 3, and hour 4. No change in rate, 0. Your parents drove, okay, you stayed at 4 hours there. Your parents drove at 60 miles per hour all the way home. So you're driving 60 miles per hour all the way back home. So you're going back, so you minus 60. So you're going back home. That gives you 110 minus another 60 from that. That gives you 50. Did I do this right? 20 plus 50, that's 70, plus 50, plus 50. Okay, minus 60 gives you 50. Gave you the wrong numbers. And then you get home. Somewhere almost 12 hours. Close to 12. About there. Okay. Now it gets you 0, not quite 12, so 11 something. Probably 1150. 160 miles. So at 1150, it gets you to 0. Unless it's 60 miles per hour, that means 50 miles takes you 50 seconds. Anyways, so close to 12. So numbers 2, 4, 6, 8, 10, 12, right there. So somewhere around there, they get home. All right, we estimate and go to 170, 10, 20, 30, 40, 50, 60, 70, 100. Yeah, we count by 10. Okay. Time in hours. And this one is distance in miles. So we do 20, 40, 60, 80, 100, 120, 140, 160, 180. Okay, we only need to 170. So we start out at 20, 0, 20, 120, 2 also at 20, and then increase 50 miles per hour, 3, 4 is 1. 3 is 70. 4 is 120. 5 is 170. 6 is 170. 7 is 170. 8 and 9 are all 170. Okay? And then 10 is 110. 11 is 50. And 12 is there. Okay? So it goes. Alrighty. Write an equation of a line to represent each piece of the graph. Okay, piece 1 is from 0 to 2 hours. 0 to 2 hours. You see that? 0 to 2 hours. How you would write that. 0 to 2. Notice it's all the domain. Rewrite the domain. 0 to 2 is y equals to 20. Okay. And the other easy horizontal one is 5 to 9. Uh-oh. 5 to 9. 5 to 9. That is y equals to 170, notice. Okay? Now to find the other two, we get y minus y1 equals to m parentheses x minus x1. We use point slope because we can find the 2 points between 3, right? 2 to 4 hours. So 2 here to 5 hours, and right there. 2 to 5. 2 to 5 hours. Okay, we need to first find slope. M equals to y2 minus y1 over x2 minus x1. Finding slope. Okay, let's use 2. That's 2 points. We use 2 is 20. That point there. And 3 is 70. So those are the 370. I want to leave room for my other one. So 70 minus 20 over 3 minus 2, which is 50 over 1, or just 50. Notice it's the same as the one on your speed here. Okay, so we use this formula y minus y1. So y minus y1, which is 20, equals to m, which is 50, times x minus 2. Y minus 20 equals to 50x minus 100. Add 20, add 20. That gives you y equals to 50x minus 80. Okay, 55. That's the third equation. I mean, that's the second. This is right here is the third. The last one, okay, is, I wouldn't use the 11.5 here. I would use 10. I use 9. This is from 9 to 12. Nine to 12, or 9 to 11. Actually, let's be 11.50. 11 and 5, 6, or 11 and 5, 6, basically. Okay. You would choose 9. I'd choose 9 and 170, and 10 and 110. Find the slope, y2 minus y1 over x2 minus x1. M equals to 110 minus 170 all over 10 minus 7. That gives you negative 60 over 3. Hold on. That's a 9. This is a 9, not a 7. See how important it is to write neat? Over 1. I check myself because I know it should be a negative 60, like that. When I got 30, I know something was wrong. So I use y minus y1 equals to m parentheses x minus x1. Y minus, let's do that one, minus 9 equals to m, which is negative 60. So x minus, oh, I'm sorry. This is 170. This is 9 here. The other way. Y equals to 170 equals negative 60x plus 150. Sixty times 9 is 0. 540. Y equals to negative 60x. Oh, I don't know why I got this. 1. What's the mistake there? Plus 170 plus 170. Y equals negative 60x plus that's your third equation. Let's look. Going down, yep, that looks right. Okay, these are your 4. Okay, now make an equation no solution. No solution is when something like 4 does not equal to 10. Okay, and separate equation infinite solution, that means 4 equals to 4, something like that, you know? Okay, so basically we can put any number we want. Okay, let's do no solution first. So if I put 4 here, I'm going to start with the sides with the most rectangles there. I'm going to start with that side. So I put 3 here, 2 here. Do not use 1. I need to put do not use 1 on the test. Okay, that, distribute, and let's say this is a 4. Distribute. So 3 plus 2 parentheses x plus 4. Distribute, distribute. 3 plus 2x plus 8. Combine these two that are alike. That gives you 11 plus 2x. Now on this side here, I need to make it 11 plus 2x. So in order to be no solution, this has to be the same. So the missing number is 2. So 2x, And it has to be any number I want it here, plus 112 or whatever. So that's the side. Once you get it to 2 like this other side, you stop. So that's gives you 2x plus 112 equals to 2x plus 112. Okay, minus 112. No, you don't get rid of the constant, you get rid of the variable minus 2x. That gives you 112 does not equal to 11. That's why this is no solution. The constant, the coefficients are the same. Notice the coefficients, these are called coefficient, the number next to the variable. They're the same, but the constants are different, so leaving them not equal to each other. Okay, infinitely many. Basically, they're pretty much alike. So if I have 3, so if I'm going to change this, look here, I'm going to change these here, right there, the one with the 3. Let's give it a 5 for the first one. And let's give this a 4, and let's give this a 2. No 1s, remember. So this is 5 plus 4x plus 2. Distribute first. 4x plus 8 plus 5. Combine the like terms, 5 and 8 gives you 13 plus 4x. So on the other side, I need to make it equal to 4x. So right here, I have no choice but to put 4x, 4 there. And then it has to be infinite, it has to equal. It has to 13 equals to 13. So this has to be 13. So 4x plus the constant and the coefficient are the same on both sides of the equation. Okay, so that gives you 4x plus 13 equal to that. So you have to minus 13, now minus 4x. Gives you 0, 0, that leaves you 13 equals to 13. This is infinite solution. Infinite solution, the coefficient, the number next to a variable, are the same on both sides, and the constant, same on both sides. Okay, now I'm going to put the back